Let's first see the definition of arithmetic progression. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This is the definition of arithmetic progression. Let's see the meaning of this statement. Here we have seen this is a list of numbers and in which each term is obtained by adding a fixed number. Let's see some examples and so that we will get the clear idea about arithmetic progressions. Here we can see some examples of arithmetic progressions. For example, the first example is 1, 2, 3, 4, 5, etc. Here we can consider this list as an arithmetic progression because we have a first term here that is 1 and we are adding a fixed number. That means the fixed number is 1 here. That fixed number is adding in each term to get the next term. So 1 plus 1 you are getting 2, 2 plus 1 you are getting 3, 3 plus 1 you are getting 4. Like that you can add some fixed number, you will get the next value. In second example, you can see the set of even natural number. Here also you can see a fixed number, the constant fixed number that is plus 2. Here the fixed number is positive 2. Positive 2 is adding in each case, you are getting the next time. 2 plus 2, 4. 4 plus 2, you are getting 6. 6 plus 2, you are getting 8. 8 plus 2, you are getting 10, etc. Like that, we are adding a fixed value positive 2. Let's see the next case. In the third example, we can see 1 by 3, 2 by 3, 3 by 3, 4 by 3. That means the fixed value which you are adding here is 1 by 3. 1 by 3 plus 1 by 3, you are getting 2 by 3. Again, you are adding 1 by 3. 2 by 3 plus 1 by 3, you are getting 3 by 3. Again, you are adding 1 by 3, you are getting 4 by 3. So here is the fixed value is a fraction in this case. Let's see the third example. In the third example, we can see the fixed value 5, 0, negative 5, negative 10. So the values are decreasing here. Here also you are adding a fixed number, which is the fixed value you are adding. You are adding positive. Is here the fixed value is not a positive number. Here the fixed value is a negative value. Anyway, you are adding this negative value, negative 5. Anyhow, this is a fixed value. Negative 5 we are adding here. 5 plus negative 5, you are getting 0. 0 plus negative 5, you are getting negative 5. Negative 5 plus negative 5, you are getting negative 10. So this is a decreasing progression. Anyhow, here is a fixed value, you are adding negative 5. So that we can construct or we can make this arithmetic progression. So that this list also can be considered as an arithmetic progression. Let's see the next example. 1.2, 1.4, 1.6, like that. So that here you can see the fixed value which we are adding here is 0.2. 1.2 plus 0.2, you will get 1.4. 1.4 plus 0.2, you are getting 1.6. Then again you are adding positive 0.2, you are getting 1.8. So like that we are adding a fixed value here, we can obtain this. See the next example. Here the progression is, or here the list of number is 5, 5, 5, etc. Is it an arithmetic progression? Yes, obviously, because here also you can find a fixed value. Here the fixed value is 0. You are adding 5 plus 0, you are getting next time that is 5. Again you are adding the same fixed value that you are getting the next time. Again you are adding the same value, you are getting 5. Anyhow, the fixed value is 0. Whatever it is, there is a fixed value we can add to get the next time. So that this is also an example of arithmetic progression. Now let's try to generalize the concept of arithmetic progression. Let's take the first term of an arithmetic progression as small letter a. And the common difference, that means the fixed value which we are adding, we can take it as small letter d. Let's add the value d to get the next term of this arithmetic progression. So first term is a. So we know as per the definition of arithmetic progression, second term will be obtained by adding this fixed value. A plus d will be the second term. And third term will be the value which we are getting by adding d again. That means a plus d means we are adding 2 times d. A plus d, that means a plus 2d. Next value is a plus 3d. Like that we can find infinitely many values for this arithmetic progression. If the number of terms in an arithmetic progression is finite value, that arithmetic progression is called a finite arithmetic progression. And the number of values or number of terms in an arithmetic progression is infinite, then that arithmetic progression is called infinite arithmetic progression. Anyhow, we have an arithmetic progression in a general form like this. It's an arithmetic progression having first term a and the fixed value which we are adding, that is called the common difference. Common difference d and first term a. Then the general form of an arithmetic progression is like this. So that we can construct an equation to calculate the nth term of an arithmetic progression. Let's denote the first term of this arithmetic progression as a1, second term as a2, third term as a3, and fourth term as a4. And now we can try to make an expression for making or finding nth term of this arithmetic progression. We can see here a1 is equal to a. Let's start looking at the second term onwards. A2 is equal to a plus d. A3 is equal to a plus 2d. A4 is equal to a plus 3d. So that you can find nth term of this arithmetic progression as a plus n minus 1 into d. So that you can generalize this equation to find nth term of an arithmetic progression. You can use this equation an is equal to a plus n minus 1 times d. Now let's try to find an expression to calculate sum of first n terms of an arithmetic progression. Now, first of all, let's take a simple example. Sequence of our natural numbers 1, 2, 3, 4, etc. This is an example of arithmetic progression. And let's try to consider, or let's try to find the sum of this arithmetic progression up to 100. That means if we are trying to find the value of the sum of the natural numbers starting from 1 to 100, let's try to find the value of 1 plus 2 plus 3 plus 4 plus etc plus 100. Then what is the value of this? Instead of adding these numbers one by one, let's imagine the sequence of numbers, and let's observe from this sequence that first number is 1 and last number is 100. If you are adding the first and last number, let's add this number 1 and 100. So 100 plus 1 or 1 plus 100, you will get 101. Now let's try to imagine the second number and the second last number. Second number is 2, and we know the second last number is 99. If you are adding 99 plus 2, here also 2 plus 99 also, you are getting the same value 101. Again, let's consider the third number and third last number. Third number is 3 and the third last number is 98. So 98 plus 3 also you are getting 101. So that you will get in the middle. If you are continuing like this, you will get in the middle 50 plus 51. So that answer is also 101. So that we can just multiply these 101 into the number of 101s. You know, the number of 101s are half of the total number of numbers. That means the total number of number is 100. So half of 100 is 50. 50 into 101. This is the sum of, instead of adding these all numbers, we can easily find the answer by multiplying 50 and 101. So this answer of this product will be the sum of these terms. This will happen for any arithmetic progression. Let's take another example. I am taking another example of 2, 4, 6, 8, 10, 12. This is also an arithmetic progression. This is also a finite arithmetic progression. Finite number of numbers are here. Let's try to add all these numbers. Instead of adding all these numbers as we have seen now, we can take the sum of first term and last term. So first term is 2 and last term is 12. If you are adding 2 plus 12, you will get 14. And again, if you are adding 4 plus 10, again you will get 14. And if you are adding 6 plus 8, again you will get 14. So 3 14s are there. So instead of adding these all, we can just multiply 3 times 14. Or you know, the number of numbers here is total 6 terms are there. That means You are getting this by dividing the total number divided by 2 into sum of first term and last term. That means first term is 2 and the last term is 12. So this equation is working for any arithmetic progression. So total number of numbers or total number of terms divided by 2 into sum of first term and last term. Let's try to make an equation. If we want to find the sum of n terms of an arithmetic progression, we can use the equation n divided by 2 into first term we can represent as a1 plus last term we can represent as an. So this is an equation to calculate sum of n, and we have already seen that we have calculated and we have discussed an equation to calculate nth term of an entity. Here you already know an is equal to a plus n minus 1 into d. Let's try to substitute this an into this equation. If you are substituting this equation, you can rewrite this equation as Sn is equal to, Sn means sum of n natural numbers, sum of not n natural numbers, sum of n times of an arithmetic progression is equal to n by 2 into a1 plus. So the first time we can take it as a plus. Here we are taking the first time as a. That's why I took first time as a here. A plus n minus 1 into d. And simplifying this, you can write this as n by 2 into a plus I can be written as 2a. 2a plus n minus 1 into d. So this is another equation to calculate sum of n natural numbers. So that we have two equations. So these are the two equations we can use to find the sum of n natural numbers of. These are the two equations which we can use to find sum of n terms of an arithmetic progression.